Hello everyone, I'm Stefano Marchesi, and in this talk I will present new insights on early black hole accretion from simulations of X-ray surveys with two future missions, Athena and the Axis probe. The results of this talk are reported in this paper, which has been recently published on ANA. So the scientific goal, which is the starting point of this project, is the search for early supermassive black hole accretion. We know that most of the early supermassive black hole accretion at redshift greater than 3 is expected to take place in a heavily obscured environment, where a lot of gas surrounds the accreting supermassive black holes. Therefore, the characterization of heavily obscured AGN is key to get a complete census of the AGN population and to understand where most of the accretion takes place. In the local universe, this heavily obscured AGN can be better studied above 10 keV with new star. As you can see in this plot, most of the observed emissions in heavily obscured AGN is observed above 10 keV, where the so-called Compton amp, the reprocessed emission, is. Moving towards high redshift, instead, things change, and since that amp moves below 10 keV, instruments like Chandra and XMM become more effective in targeting these heavily obscured sources. So, optical and near-infrared surveys are biased against obscured AGN at high redshifts, so one needs X-ray facilities to get a complete census of these accreting supermassive black holes, and needs deep surveys to reach these very faint or heavily obscured sources. The problem is that the two most powerful X-ray telescopes currently available, Chandra and XMM, are more than 20 years old, and Chandra, which is the only sub-second X-ray instrument, has seen a significant worsening in its effective area, as it's shown in this plot, and this limits its efficiency as a survey instrument. An XMM Newton 2.0 is being developed, it's Athena, but no X-ray instrument with Chandra-like spatial resolution has so far been cleared for development. A candidate Chandra successor is the Axis probe, which has been submitted to the NASA 2020 Decadal Survey Review. This instrument would have a sub-second resolution over a wide field of view, as we can see in the right plot, and a large effective area. It would work perfectly with Athena, together with Athena, because Athena will have an excellent, unprecedented effective area and a very stable but larger PSF, as it can be seen in the left and right plots. We therefore built mock catalogs of AGN non-active galaxies and clusters of galaxies to simulate surveys with Athena and Axis to try to understand how well these instruments will allow us to understand the high redshift universe. These mocks are based on extrapolations of best observational data and population synthesis models, and are available online at this webpage. So this is a flux versus area plot for current available X-ray surveys and for the simulated Axis and Athena ones, and you can clearly see how Axis and Athena will really open a new window of knowledge. Here there's a summary of the results of the detections that would be obtained by these two surveys. Overall, Axis and Athena could detect up to 500,000 AGN, assuming no overlap between the two surveys, and 90% of these objects will be detected for the first time in the X-rays. The detection of such a large number of X-ray sources will require also a big effort in terms of counterpart identification and redshift measurement, which will require these new X-ray missions to work in synergy with optical and near-infrared missions, such as LSST and the Roman Space Telescope. So moving to the high redshift, we expect to detect up to 20,000 sources, an enormous improvement with respect to the fewer than 500 that we see now. Athena will detect more sources in the high luminosity regime, and in general we detect more counts, allowing for X-ray spectral follow-ups. Axis will detect the low luminosity tail. And the tracking of sources up to redshift 8, 9 will make possible for the first time to track the accretion of the first accreting black hole seeds, distinguishing between different models of accretion. Here you see an example between a light seed and a heavy seed accretion scenario. And finally, Axis and Athena will detect about 80 sources at redshift greater than 3, And this will make possible to constrain the X-ray luminosity function with 50% uncertainties up to redshift 8 and up to very low luminosities. And this will allow for the first time an unprecedented tuning of theoretical models. In this plot you see the range of all the possible predictions of theoretical models from Marantidis et al. The addition of X-ray data from Athena axis sampling a range of luminosities way lower than before will allow us to tune these models extremely better. I leave here my conclusions. Thanks for your attention.